Let's take a look at how Xbar and R charts are created and how to interpret them. Throughout this course, you've learned that when we look at data, we look at 5 things: center, shape, and spread, how we perform versus target, and how we perform over time. You've already seen a lot of tools like histograms and box plots that tell you the center, shape, and spread of the data, and you've also learned that you can put a target line on there that will let you know how you're performing versus target. So the purpose of control charts in general is to see how we perform over time. The specific purpose of an Xbar chart is to tell you your average performance over time. And remember that process stability is all about the center, shape, and spread of the data staying consistent over time. That's what makes this process predictable, which is very good. So what you do for each time period is collect a subgroup of data. This could be 3 observations, 5, 8 observations, whatever you decide is appropriate. You calculate the average of each of those subgroups, and that's what gets plotted on the Xbar chart. But remember, this is about center, shape, and spread being consistent over time. There is absolutely nothing on an Xbar chart that lets you know about the spread of the data within each of those subgroups. That's where we remember that we've learned a number of measures of spread, such as range, standard deviation, and variance. We're going to need an additional control chart that looks at the spread of the data to let us know if we're really a stable process or not. In real life, when you run this, the Xbar chart will always travel with a little buddy like an R chart. What the R chart stands for is a range chart. For each of the subgroups of data, it will take the highest minus lowest value from your sample, calculate the range, and plot it as a dot on that chart. Let's take a look at the dangers behind Xbar charts. Averages mask variation. So the Xbar chart is showing averages. Take a look at this typical chart. Notice that observations number 1 and 3, the first and the third dot, look to be very similar to each other. Let's go behind the scenes. Behind the scenes of this first dot, we'll make this very simple. Your subgroup could have 5 observations. It could have 13 observations. To make the math simple, I'm going to assume that we only have 2 observations behind each of those dots. And in subgroup 1, the first observation is 49. The second observation is 51. That totals up to 100. It gives us an average of 50. And we take the high minus the low, 51 minus 49. That gives us a range of 2. So we'll take that 50 and we will plot that as the first dot on the Xbar chart. We would do likewise for subgroup 2, but let's go over to subgroup 3. This is interesting. A casual observer would say that must be almost exactly the same as subgroup 1 because the dots are extremely similar to each other. Well, let's see. For subgroup 3, the first one you measure comes out as 2. The second one comes out as 98. That still totals up to 100. It still gives you an average of 50. You plot that 50 on there. Again, a casual observer would think that the first and the third dot must have exactly the same thing going on behind the scenes in its subgroup. But in reality, subgroup 3 has a massive amount of variation going on inside of it. It has a range of 96 compared to the range of 2. So that's why the Xbar chart travels with its little buddy, the R chart. R stands for range. The center line on an R chart is R bar. That's the average range. The lower boundary always bottoms out at 0. You can't have a negative range. Now in this case, we're going to take our first dot and put it on there at 2. We'll do likewise for the second dot. But now it comes time to plot this guy, 96. This bad boy is a rocket ship to the moon. Literally, look at the ceiling of the room that you are sitting in right now. That's where this dot would land. Off the charts variation. This chart is screaming at you as loud as it possibly can, and it's saying you have a massive amount of variation in subgroup 3. Now, all of the tests apply to the range chart just like they do the Xbar chart, so we violated test number 1 in our third dot. So to read these, what looks like a stable process with nothing going on the Xbar chart could actually be masking a lot of variation, which is why it travels with the R chart. In reality, we have a lot of variation going on, and this is an unstable process regardless of what the Xbar chart tells you. So as you look at an Xbar chart in the Sigma Excel output, know that the alarms do apply. You could get little red numbers on an Xbar chart. You could get little red numbers on an R chart as well. When you look at the dot on an Xbar chart, that is an average of your subgroup. The space between the dots on an Xbar chart indicates the variation between subgroups. The dots on the R chart show you the variation within subgroups. So what have we learned so far? We've learned that range charts can often detect within subgroup variation that Xbar charts are totally incapable of seeing. This is why they travel together. Maybe you've heard the old adage that a man with his head in the freezer and his feet on the stove is, on average, comfortable. That's the danger of averages. Averages mask this variation. The range chart helps to unveil that variation if it exists within a subgroup. So they travel together. You should look at the range chart first. If you see any red dots, if it is unstable, then the process itself is unstable, and you cannot really believe what you see in an Xbar chart. If the range chart is stable, you should go on and evaluate the Xbar chart to see if it's stable. Again, if it is not stable, the process itself is unstable. So in other words, both the R chart and the Xbar chart both need to be in control for you to determine that the process you're reviewing is stable. And that's how to prepare and read an Xbar and R chart.